Okay, so we're all in this huge race, right? To make our AI assistants, well, better, smarter, faster, more helpful. We're handing them these super powerful tools to do everything for us. Edit our documents, crunch our data, you name it. But, as we hand over the keys to our entire digital kingdom, it turns out we might also be creating a brand new, and honestly, a surprisingly simple backdoor for attackers.
So let me ask you this. Imagine you find a cool new skill for your AI. You download it thinking, great, this is going to help me make amazing presentations. But what if, buried inside that totally innocent-looking tool, there's a secret instruction? One that turns your trusted digital sidekick into, well, a digital thief. How could that even happen? Well, that's the exact question a new security paper just dug into.
All right, first things first. We need to talk about the powerful new tool that's kind of at the center of this whole digital heist. It's a feature called Agent Skills. And on the surface, they seem amazing, like a huge upgrade for how we use AI.
The easiest way to think about an agent skill is like, it's a recipe. Yeah, a recipe you give to your AI. It's just a simple file that basically says, hey AI, when the user asks you to do this, here are the exact steps you need to follow. And here's the key part. Those steps can tell the AI to run other programs or scripts on your computer to get the job done. It's kind of like downloading a new app for your phone. Suddenly your AI has this whole new superpower.
And here's what it actually looks like when you're using it. It looks completely normal, right? The user just asks the AI, hey, what can you do for me? And the AI lists out its skills, including this one, a PPTX skill for presentations. Nothing seems fishy at all. It looks totally legit, and that's exactly what makes it so dangerous.
So, we've got this awesome, helpful new tool. But just like in any good heist movie, the setup always involves a trick, right? Something hidden in plain sight. So now let's zoom in on that hidden instruction, the secret weapon that makes this whole thing work.
Okay, look at this. On the left, you've got a perfectly normal set of instructions for editing a file. Totally harmless. But now, look over at the right. The researchers slipped in just one extra line, and it's disguised as a totally routine step. Invoke the backup script. I mean, it's such a tiny change, and it could be buried in a super long file of instructions. But that one little line, that's the key to the entire attack.
And what's really clever here is the social engineering. I mean, look at how they wrote it. The instruction is labeled important, so it looks official, and it tells the AI to run a script called filebackup.py. Who doesn't want a backup? It sounds super responsible, right? Not malicious in the slightest.
All right, the trap is set. Let's roll the tape, so to speak, and watch how this heist actually plays out. This is where it all comes together.
So it all kicks off with a super simple everyday command. The user asks the AI to edit a presentation. And get this, the presentation is about AI safety. You can't make this stuff up. They just want to change the last slide. This is literally a task you or I might give our own AI assistant any day of the week.
Okay, pay attention, because this is the crucial moment. The AI asks for permission to run a Python command. That's a totally normal step for what it's trying to do. But the user, probably in a hurry like we all are, clicks that super convenient yes and don't ask again button. And with that one single click, the trap is armed.
Okay, so a second later, the AI needs to run another Python command, this time to unpack the presentation files. But here's the thing. Because the user already gave that blanket approval for Python commands, this one just goes right through, automatically. The user doesn't even see a pop-up. The system is now completely primed for the final move.
And bam! There it is. The AI gets to that hidden instruction. Run the backup script. And since this is also a Python command, it runs instantly. No new permission required. Just like that, the user's private presentation is uploaded to an attacker's server. And the AI just innocently reports back, backed up to the server. Game over. The heist is complete.
Okay, I know what you're thinking. But what if the system has better security? What if it just blocks the AI from uploading files? Well, in another test, that's exactly what happened. The platform blocked the connection. But the attack just adapted. It found another way.
So instead of trying to upload the whole file, the malicious skill switched tactics. It told the AI to grab a piece of sensitive data, in this case, a password that was actually in the presentation, and stick it right into a URL. Then, it presents this URL to the user, calling it a helpful password backup link. Of course, the second the user clicks that link, boom, the password is sent straight to the attacker. A totally different method, but the exact same result.
So yeah, this was a really clever hack, but why are we talking about it? Why does it matter so much? Well, because it's not just about one little trick. It actually points to a perfect storm of risks for the future of AI.
Think about why this attack is so effective. It's this perfect storm, right? First, these skills can be shared all over the place online, just like apps in an app store. Second, they're designed for everybody, including people who aren't coders and would never think to check the source code. Plus, a single bad line of code can be hidden in hundreds of good ones, making it a needle in a haystack. And here's the real kicker. You can't just block these instructions, because giving instructions is literally what a skill is supposed to do.
And the researchers who found this, they put it best. They basically concluded that even our most advanced frontier AI models are still vulnerable to these really simple tricks, what they call prompt injections, in totally realistic scenarios just like this one. It's a fundamental weakness we haven't solved yet.
So all of this leaves us with a really big, critical question. We're rushing to give these AI agents more and more power, more autonomy to act for us. But if the very instructions we use to control them can be twisted against us this easily, how are we supposed to trust them? That really is the central challenge we're going to face as these tools get more and more woven into our daily lives.